welcome to my talk, one of the last talks of the day. I want to take you on a journey from J2EE to Jakarta EE. And well, my name is Dirk. I'm from Gedoplan. We are located in Bielefeld in Berlin. And I'm doing Java, well, nearly from the beginning. Mainly with enterprise technologies, so application servers, application frameworks, like Java EE, Jakarta EE, Kubernetes as well, and I'm a frequent speaker on conference. I've been on the JCON last year and the year before, I think. So let's go into our talk and start with 1999. That was the date when J2EE was released. That was done by Sun, and maybe you remember this diagram that they had on their website explaining how they thought that enterprise applications were built. And what they invented was a specification, or better, an umbrella specification with many parts and individual specifications developed as open source. But that's not quite right. It was community driven. It was not open source in the same thought and thinking that we have today. And one of the main parts maybe were enterprise Java beans. There's another diagram that's in German. Sorry for that, but it's not important. And with enterprise Java beans, they had a very far-sighted idea of components where we can build our business logic into, and we can combine them declaratively. And we had scopes. For the time then, it was session scope, for instance. And we had declarative transaction control. That's our key factors for success at that time. And the only thing was, it was too complex. Who of you had the chance to work with EJB 2.1 or earlier? You have my deepest thoughts. It was too complex. Why was that? Well, let's have a look into one demo. So let's think of two services, a hello service and a world service. They should call each other, and we want to program it as EJBs. And at that time, for that simple task, we had to program 6 Java artifacts. So 4 interfaces and 2 classes. And that is not the end of the story. If you wanted to have some remote service, we would have to implement or program another interface for the boundary. And I think the reason why we did that at that time was for some reason we thought that we had to program against interfaces all the times. So it wasn't possible to connect classes with or objects of classes with each other. We had to go through interfaces, even for lifecycle things like factories. So creating objects had to be done by calling classes in interfaces. And even more, we had to program a quite extensive XML descriptor for that, where we could specify the connection between the 2 classes, or the 2 beans. That is old code. It's not really nice, but the thing is, that still works. Yeah, let's have a look into that. Let's make a demo for that. So I have a little project here. You can find that on GitHub after after the talk. And there are those beans that I showed you before. And I packaged that into an application and started that on a JBoss 6. Little disclaimer for J2EE 1.4, it would better have been a JBoss 4, but I didn't find a working Docker image for a JBoss 4 on my machine. So I use the JBoss 6. That is technically a Java EE 6 server, but the code is exactly like meant for J2EE 1.4. So if I run that on my machine in a Docker image on a JBoss 6, we can see it starting here. It's quite slow, and will display some errors, but they are not connected with the application. And in the end, it publishes a web interface, which I can curl into, and it will tell me hello world. So that calls the first service an EJB that connects to the second service, another EJB, and combines the two results into one string. Nothing fancy here, it's just technique. So, but the same exact application. I'll stop the JBoss 6 one. I didn't change anything about the application. It's exactly the same WAR file there. And I start it on a Whitefly 26. That's a quite recent Jakarta EE server, Java EE 8 server. So let's have a look at the log. It's starting, it has started already. And if I curl into the same endpoint, I'll get the same result. It's exactly the same application, and that's one of the key values that you have in the J2EE, Java EE, Jakarta EE world. You have backwards compatibility. You can use your applications on recent application servers. You don't have to modernize your application all of the times. So what was next? 2006, Oracle had acquired Sun, and they took over, and they renamed it into Java EE5. Well, none of us did understand the 2 in the name before, I think. What was one main influence was the Spring framework. Spring framework invented in 2003, 2004, I think. And they had a very good idea of dependency injection. They thought, and they were right, that EJB is too complex, and we have to do it the other way around. And dependency injection was the method used there. And then the JAE, the J2EE, the J2EE, Java EE folks said, cool, let's do that too. And we now have Java 5, so we have annotations and can get rid of many contents of the XML descriptors. We can put that into the code, so we can reduce complexity at that case. And we can get rid of the home interfaces, that were the factory interfaces. We don't need local interface for connecting beans locally with each other. We can inject them into each other by an annotation at EJB. And descriptors could be made optional. Well, that was technically the case with Java EE 6 then. But many parts of the descriptors could be left out then. And they moved persistence into JPA. Persistence was a part of EJB before, which was not a good idea, and they moved that into a different specification, Java Persistence API. So that led to much more simple code. the same bean that I showed you before could have been programmed like that now. So it's just a simple class, it's annotated, that replaced parts of the deployment descriptor, and the connection between the beans is made up by injection, by annotating a instance variable here with @EJB. That's it. That was very simple. That was a revolution. But we as community, as developers, as users said, well, I still think it's dumb. Why is that? Why didn't we recognize the value that was in that change? I think that's because we as humans have problems to regard a positive development if something has been regarded evil before. So EJB was evil, and you could incorporate improvements there, and we always thought again it was evil, without any reason. Yeah. So, 2010, Java EE 6. There, the Java EE folks said, okay, if you don't understand what we did with EJB, how we simplified that, we try a new name, CDI, context and dependency injection, quite complicated name. And that led to that code. Simple class, annotated with a scope annotation, application scoped here instead of stateless. That's not technically exactly the same, but for the sample here, that works. And injection done by @inject instead of @EJB. And now we as a community said, wow, cool. That's it. Yeah, that's lightweight. Whereas the code that we saw before was heavyweight. If you find someone who can explain that to me, please tell him. If you look at it in detail, the code hasn't changed much. Yeah. So there is no technical reason for regarding CDI lightweight, whereas EJB3 is heavyweight. But that's us. Yeah. Okay. Let's have a short timeline. J2EE, the start of this thing, then Java EE 5 with several improvements. I will not read that to you. You can read by yourself. But it was simplification. Java EE 6, more simplification. And after that, Java EE 7 and Java EE 8 kept up with developments in the Java language itself. So new data types that could be mapped, for instance, in persistence and so on. And a focus on web applications, cloud, and so on. Yeah. And with this version, that was the end. The end of development of Java EE 8, version 8. Yeah. That is because, I will come to that later, because Oracle decided to give the project into an open source project hosted by the Eclipse Foundation, like we have that today. And but let's shortly talk about 2 years before that happened. That was 2016, where microprofile came into play. And that was because we had new impacts, new demand for writing microservices, cloud-ready services, and use clouds privately owned or public. And that meant the demand was to have something in the platform supporting that. So easy configuration, for instance, by environment variables, or monitoring, health checking, and so on. Everything that are named is quite easy in the end, but it should be in the platform. but some way nothing happened. It seemed as if the JCP or Oracle or both were standing on the brake. There was also no communication. We didn't even know if Java EE was really at the end. So it would be deleted from the market. Yeah. And maybe you know this name, the Java EE Guardians, an organization of interested individuals and companies that tried to build some weight against Oracle, ask Oracle what is happening here, can we help? Yeah. And in the end, Microprofile was invented as a separate open source project hosted by the Eclipse Foundation, containing all the things that I mentioned before, like easy configuration, health checking, monitoring, and so on. And the idea there was you can build that on top of Java EE if you have CDI and JSON and REST web services. That's it. Yeah? So configuration can be done with CDI producers. Health checking can be done with CDI qualifiers. Metrics can be done with CDI interceptors, and so on. So there is technique, supporting technique enough to implement those little services. And I think the name Microprofile tells us that they thought if the weather has calmed down, that could be integrated into the platform as additional profile. We had profiles, we had web profile and platform or full profile. So Microprofile could be a third profile in the Java EE ecosystem. That didn't happen. It may happen with Jakarta EE12. On JavaLand, I had a discussion with Emily about that and Eva, so maybe that happens in the future. It's important to know that all the implementations of Java EE implement Microprofile as well. So you can regard that as one big specification. There is no such thing like a Microprofile server. It's a server that can do Microprofile plus persistence or faces or whatever. Yeah? And there are many, many implementations that can do that. Okay, Jakarta EE8, that was 2019. In 2017, Oracle donated the project to the Eclipse Foundation. So that's 2 years later. Why 2 years later? That's because Oracle kept naming and copyright. So everything had to be renamed. Java EE became Jakarta EE, Java Persistence API became Jakarta Persistence, and so on. That's text replacement at first place, but you have to rewrite all the specification documents to get intellectual property out of the documents. And that took 2 years. Yeah, so Jakarta EE8 released 2 years after Java EE8 had no functional change. It's exactly the same code apart from some Maven dependencies. Yeah. And the concept of a reference implementation was gone in favor of compatible implementations. But the code itself of the platform and the service and so on is exactly the same. So no change apart from documents in 2 years. Yeah. So we have 2 years without any improvement, yeah, in technical respect. Improvement in documents, yes, but not in technical respects. And it comes even worse. With Jakarta EE9, we had Oracle keeping also authors' rights for package names, JavaX.something. was allowed to be used in Jakarta EE, but not modified. But it's not all JavaX packages, it's only a few of them belonging to the EE ecosystem. They had to be renamed. The decision was to do that as a big bang. And release of Jakarta EE9 1 year later, again with no functional change, but with renaming of the package names. And it's not only package names, it's what we always talk about, but it's also Maven coordinates. Package name is yes. Deployment descriptor schema. Property names in deployment descriptors. And tag-lib names for faces. So several parts that had to be renamed. Luckily, there are tools that come to your rescue if you have to do that. Have a look into Open Rewrite. They have recipes for renaming all the things, but it has to be done. Another year without progress and technical decisions. But then, with Jakarta EE10 in 2022, we had a version that is on new package names, on new property names, without intellectual property of Oracle and so on. And the main focus of Java EE10 was CDI alignment. Maybe you know that in the years before, many of the part specification had their own injection frameworks. Like, of course, EGB, but also faces and rest of services and so on. And that should now be focused on CDI, so CDI should be the one injection solution in the whole platform. Not all of that came really into Jakarta EE10. So for instance, the injection annotation of JAXAS, which is now Jakarta REST Web Services, at context should have been replaced by at inject. That is done in Jakarta EE11 now. Or asynchronous, that's in the Jakarta concurrency specification now. At log and at schedule are just waiting for that, and so on and so on. But the main thing with CDI was also a split up to make it possible that frameworks or tools like Quarkus can use a part of CDI for their work and use build time artifacts. You may know that. Who knows Quarkus? Okay, so you know that Quarkus does build time augmentation. So you have code that is prepared at build time and then loaded into your runtime to make it possible that you can run the application without inspecting your code at runtime. So you can use build time code instead of runtime inspection. And the interesting thing as a side note is that we had that with EGB 1.0. If you remember that, if you are old enough to have been engaged with EGB 1.0, you know that in your development environment you create a Java object which was serialized and then loaded into your runtime. That's exactly the same idea. Using Java serialization was not the best idea for that. Quarkus uses bytecode, that's better. But the idea of having build time code running in your production, that was 1999. And we forgot that in between. So now we have the 11th version of Jakarta EE11, and that took much more time than I thought it would take. Mainly, I think, because of renovating the TCKs. That is one big issue that has been done with this version of the specification. The core profile was released in December last year. In March, we had, or we have the web profile now, and well, it should be a matter of a few weeks for the full profile now. What is new there? We have support for Java 17 and Java 21. We embrace records. We can have a look into some demos there, codes there. I have to open a different project. What you can do now with records is, for instance, you can use records as embeddables. So if you have a record like that address, you can use that in an entity as embeddable. So address is somewhere here. Or you can use records for DTOs. So if you're selecting data with JPQL, for instance, and have a constructor expression, you can use records for that. There are other minor enhancements that you have in Jakarta EE 11 or in Java Persistence that I think is the version 3.2. Quite interesting is that you have an built-in converter for enumerations. So the status is an enum, and before you had the mapping possibilities to write the ordinal number or the constant name into your database, but now we have the possibility to define an enumerated value in your enum, which is then used for populating your database. So you have an inbuilt adapter, value adapter. That's quite interesting. Or another small detail, not quite sure if I have that in my demo here. Look. You know that in the versions before, you normally cannot use the execution method get single result from JPA because that may throw an exception, and if you throw an exception, the entity manager is not capable of committing any transaction anymore. And now there is a method get single result or null. So if the query doesn't find anything, a null value is returned instead of throwing an exception. So that's, there are many small enhancements. Maybe one mapping enhancement, you can map UIDs. No, that was in Jakarta EE 10 already. Okay, so that was records and some other improvements. Then you have virtual thread support. Virtual threads is a big thing for Java 21, and well, you can use virtual threads in Jakarta EE 11 application server. So how can that be done if the base version for the server is Java 17, where you don't have any virtual threads? Well, that is done by a parameter with which you can create a managed where is it? Managed executor service should be here. So that's it. And you see, you can define your thread pools, your managed thread pools by a definition annotation here, and that incorporates a Boolean parameter here, virtual equals true. And if your server runs on 21, then it will use virtual threads. If it runs on an older version, it will use platform threads instead. Yeah. So that's the trick that you can use here. I have a demo for that. If you want to try that out, the demo runs on OpenLiberty only. It does not work on Whitefly. Without me knowing why, yeah? Because Whitefly tells me that concurrency 3.0 is implemented, but it doesn't work at that respect. Okay. Yeah, various enhancements in persistence and CDI, I did mention that already. And then we have a new specification, Jakarta data. And I didn't prepare a showcase for that for this talk because I thought there will be lots of talks on the JCON about Jakarta data, which is obviously not the case. So a few words without any demo for that. Jakarta data has three key features. It's an abstraction on top of relational databases and non-SQL databases. It gives us a possibility to create repositories for querying the databases in quite the same way that you might know from Spring Data JPA, where you can use interfaces to specify your queries, and by some magic, when starting your application or deploying your application, the implementation of the repository is created. The last thing is that Jakarta data is stateless. So that is a big thing if you think that you can use your relational model that you have with written with Jakarta persistence and use a repository from Jakarta data on top for querying. That will work only if you don't have any lazy attributes or if you don't have any relations in it. Because in Jakarta data 1.0 that is not supported. So maybe that is also a reason why we don't find any talk about Jakarta data. Maybe it has to be, it must mature a little bit. Okay, one thing about competition. We have the Spring ecosystem and we have the J2EE and Java EE, Jakarta EE ecosystem, and they influence each other, which is a good thing. Yeah. As I mentioned before, J2EE was too complex. It was mainly EJB which was too complex. So Spring said, let's do dependency injection. That was honored by Java EE as well, as I said before, by incorporating dependency injection into EJB. Then EJB had annotations instead of XML. That went into the Spring ecosystem as well. So Spring, for the first version, had XML descriptors. And they do that with annotations now as well. Then came Spring Boot, 2014, I think. 2014, 15. With the idea, let's package the server into the application. We don't need two artifacts, a server and an application which gets deployed onto the server. It's just one thing. Let's incorporate the server into the application. Yes, the application server did that as well. I used Whitefly as a placeholder here. You can think of Liberty or Payara as well. They all did the same thing, combine the server and the application in some bootable thing. Whitefly calls this bootable jar. I don't remember how the other servers call that, but it's exactly the same thing. So you can have a server run as a jar file, including your application. Yeah. Technically, internally, it's a server where the application gets deployed onto, but you don't see that. It's just one artifact that you start. Spring Boot had another idea: compose applications from starters. So they have different dependencies that you can use as building blocks for your application, and build your application from exactly the same the things that you need. Make it smaller. Yeah? That is done by Quarkus as well. Quarkus is, if you want to say name it, it's Spring Boot based on Jakarta EE. It's exactly the same thing. They call it extensions, what Spring Boot calls starters, but it's the same thing. And Quarkus has native mode. You can compile your application by the help of GraalVM or a Mandrel into a native code application, which starts very fast in milliseconds. That is done by Spring Boot now as well. Not in exactly the same way, but it's the same direction. Yeah? And so you see the both ecosystems influence each other. Competition keeps things moving. I think neither Spring nor Jakarta EE would be on the same level as we have it today if the other didn't exist. Yeah. Okay, let's come to an end. What's the charm? I named my talk 11th times the charm. So the 11th version is a good thing. Yeah. So what is the good thing there? It's a standard. Jakarta EE is a standard. It's modern and mature. Integrates current features. We saw that virtual threads, binding of current Java attributes, and so on. We have new standards, so the platform evolves into new things like data concurrency and so on. And well, it's backwards compatible, at least after the package rename. Yeah. The package rename from Jakarta EE 8 to 9 breaks this principle. But after that, we have backwards compatibility again. Yeah. The servers, Whitefly, OpenLiberty, Payara, and so on, they are lightweight. Many people say servers are heavyweight. Well, in terms of starting time and memory usage, you can judge that. And they even have a single jar mode, this so-called bootable jar, if you want to use that. And you can even customize your server to only the layers, that's how Whitefly calls that you use in your application. And if that is not enough, you can use microframeworks. I used Quarkus on my slides, but there are others like Helidon, which are small, quick, sexy. Yeah. And as I said, Spring Boot, but based on Jakarta EE. Okay, that's my 50 cents. If you want to have a look into the projects, you can go on GitHub and check them out. There are readmes in there. You can try that out with a short you. The slides are on speaker deck. And yeah, if you want, have a look on our website for blog entries and so on. Are there any questions? Have a look into Slido if there is something. So the last one I take this first is Microprofile is strict superset of Jakarta EE. No, Microprofile is an addition. So Microprofile is these 8 yellow boxes that I had, like config, fault tolerance, metrics, and so on. and it uses a part of Jakarta EE that is CDI and JSON binding and JSON processing and Jakarta REST web services. That's it. Yeah. So in Jakarta EE, there are more specifications like persistence and even EJB is still in there, and security and so on and so on. That is not technically not part of microprofile. But as I said before, all the servers, all the frameworks that we have implement both. So don't think of two separate specifications. It's one big thing. Yeah? And maybe microprofile gets integrated into Jakarta EE sometime, maybe in the 12th version, which is under development now. Yeah. So that was that one. And do you know whether there is any CDI Lite implementation for desktop or Android that builds the dependency graph at build time like Dagger, apart from Quarkus? No, I don't think. I don't know anything. Is anybody of you, do you know something there? Okay, okay. No. I must say for me, I'm a more backend developer or expert, so I'm focusing on Quarkus, and while the Android thing can do some, my colleagues can do Android, not me. Yeah. Okay. Okay, if there are not more questions, then thank you that you have attended my talk. That was the last talk for today. So enjoy the happy hour now and enjoy the rest of the conference. Thank you.